Hello, a very good evening to all, and welcome to my class. This is the second class of this chapter, solution chapter. In last class, what we have discussed already that there are the various type of concentration defining terms like mass percentage, volume percentage, molarity. Okay, and in today class, we are going to do some numerical based on the previous topics, that is molarity, concentration defining terms and all. So let's start with the today class. I'm audible. My screen is visible to you all. Yeah. So that we can start. Okay. So as we already know, how will you find the molarity, and the mass percentage, right? So just to revise the entire concept, we are going to do one numerical based on the topic and try to understand the whole topic by solving this numerical as well, right? So what the numerical is this beta? According to this question, calculate the molarity of Ki. You have to calculate the molarity of Ki if the density of 20% mass by mass equals Ki is given. So you have to calculate molarity of what? Of Ki. So to do such type of question, what you need? You must know what is the formula for the molarity, right? So if you know the formula for the molarity, then you can easily calculate this. For example, we all know what is molarity, beta. Molarity is represented by capital M. And how we can find molarity? Molarity is nothing but mass of the solute, divided by what beta? Molar mass. So divided by molar mass into 1000 and volume of the solution. Volume of the solution, right? So this formula we already derived in our previous class. That is how will you find the molarity. So for molarity, we need just three things: mass of the solute, molecular mass, volume of the solution, and we all said to calculate molarity. So can anyone tell me what is the mass of solute in this question? The question is given 20% mass by mass. What does it mean, beta? 20% mass by mass? Please tell me, what does it mean? 20% mass by mass. Yes. Anyone? We already discussed na beta, that is mass percentage, that is weight by weight. So what does it mean? 20%. So 20% weight by weight means what? That is 20 gram of the solute that is present in 100 gram of the solution. That is the meaning of 20% here, right? So we know that from the given question as itself, mass of the solute, that is mass of solute. So mass of solute is equal to 20 gram, right? So this is the mass of the solute, 20 gram. And what is the molar mass, beta? So molar mass of Ki. So what is the molar mass of Ki here? So molar mass of Ki is given. Right. So just for this molar mass, you need not to be worried because this molar mass is already provided in your question itself. Right. So molar mass of Ki is given, that is 166 gram per mole. Okay. This is 166 gram per mole. So this is given 166 gram per mole. So can you just calculate? Now, the big question is how will you find the volume of the solution? Because in this question, volume of the solution is not given. Then how will you calculate volume of the solution, beta? Yes, to do this, to calculate the volume of the solution, we use the concept of density. So we know that what is density, beta? Density is nothing but mass upon volume. Always remember here, this is the density of solution. So then density of the solution is nothing but mass of the solution upon volume of the solution, right? So if you have to calculate the volume of the solution, then what is? It comes out to be mass of the solution divided by density of the solution. So volume of the solution comes out to be mass of the solution divided by density of the solution. Here, what is the mass of the solution? What is the mass of the solution, beta? Mass of the solute is 20 gram. Understand? Mass of the solute is 20 gram out of 100 gram, because 20% means what? 20 gram out of 100 gram. This is mass percentage. So here the mass of the solution is nothing but 100 gram. So mass of solution is 100 gram. Similar, what is density here, beta? What is ds? So density, ds comes out to be density of the solution is provided, that is 1.202, right? So this is the volume of the solution. Anyone, any kind of doubt? बेटा कोई भी doubt है यहाँ तक please पूछ लो एक बार. कैसे निकाला मैंने volume of the solution? How I'll find the volume of the solution? Anyone? Any doubt related to this? No? Okay, so whenever the volume is not given, there is always one thing is given, and that is density. So by using the concept of density, you can calculate volume as well. Just remember one thing here, in this density of the solution is taken, right? So density of the solution must be equal to mass of the solution divided by the volume of the solution. So by using this formula itself, you can calculate the volume of the solution, which comes out to be this, that is 100 upon 1.202. Now all set to go. We know what is mass of the solute. Yes, 20 gram. We know what is molar mass. Yes, 166 gram. We know what is 1000. Obvious, it's 1000. What is the volume of the solution? It's 100 divided by 1.02. So we can write as 1.202. Now, just calculate molarity here, beta. 20, 20. They cancel out each other. Now, this comes out to be 20 upon 166 multiply by 10 into 1202 and divided by 1000, right? Divided by 1000. So cancel out. Okay, so what you will get, beta? On solving this, that is 2 into 12.02, we get 2404 divided by 1660. So just divide this term, that is 2404, right? So 2404 divided by 1660, it comes out to be 1.44. So which one is the correct option for this question? It comes out to be 1.446 molar. So the correct option for this question is, beta, option number D. So this is how you can calculate molarity by using density. So whenever the volume is not provided, always density is provided. So by using this concept only, that is the concept of density, you can calculate molarity. If this is clear to you, please text me in the chat box so that I know that there is no doubt in this question.
Sir.
Clear है सबको?
Yes, sir.
Yes. Yes. Okay, so let's do next question. This is on the similar basis. So what the question asks, beta, that is 10.30 milligram of O2 is dissolved into a liter of seawater having density this much, and you have to calculate the concentration of O2 in ppm. So we know that weight percentage and ppm as well. What is ppm here, beta? That is parts per million. The parts per million means what? That is amount of solute that is present in 1 million. Okay, so you have to calculate the concentration of O2 in ppm. So what is given here? That is mass of the solute, that is 10.30 milligram of O2, which is dissolved in a liter of seawater having density this much. So how you can calculate, beta? Mass of O2 already given, that is 10.30 milligram, and mass of the seawater. This is using the similar concept. We know that density is equal to Mass of the solution upon volume of the solution. So we can calculate na mass of the solution. How? By multiplying density into volume of the solution. So what is density here? That is 1.03. What is volume here? That is 1 liter. So we can calculate. It comes out to be 1.03103 gram. Okay. So this comes out to be, because the volume is in liter na. So when you multiply by 1000 ml, will get this. That is 1030 gram. So this is the mass of the solution. So we know that how will you calculate ppm? That is mass of O2 upon total mass of the solution multiplied by 10 to the power 6. It is very much similar to the mass percentage. In mass percentage, we use 10 raised to the power 2, or we say 100 in place of 1 million. That is 10 to the power 6. So it comes out to be 10 ppm. So this is very simple question, and this question was asked in JEE Main 2022. And in this, you just have to calculate the concentration of O2. So this is very simple question, and it is totally based upon concentration. That is, how will you calculate mass percentage, parts per million, parts per billion, and so on, right? So this is how you can calculate the question by using the simple concept. And one important note here is also density is given. So by using density, you can calculate volume. By using density, you can also calculate mass of the solution. So density play a very crucial role in this type of questions, right? Now, this is molality. So we understand and do two numerical based on the molarity. Now let's understand, what do you mean by this term molality? What is molality, beta? So basically, molality and molarity are different in a one thing, that if I'm talking about the molarity, that is the number of moles in 1 liter of the solution. It means we taking volume here. But if I'm talking about the molality, what is molality, beta? Molality means nothing but the number of moles divided by per kilogram of solvent. So here we took a solvent. As in molarity, we consider volume of the solution. So these are the important difference between these two, molarity and molality. So what is molality, beta? It is the number of moles of the solute that's dissolved in the 1000 gram of solvent. Here we are talking about the solvent, not solution. But in case of molarity, we are discussing about the solution. Right? So how we calculate? First thing, molality is represented by small m, where the molarity is represented by capital M. So we can calculate molality by using a simple formula, that is the number of moles of the solute divided by mass of the solvent in gram multiplied by 1000. Okay, so this is how you can calculate, that is mass of the solute. And how will you calculate number of moles, beta? That is, let me write. That is, we can also derive formula for molality just like molarity, like mass of the solute, that is mass of solute divided by what, beta? Divided by molar mass multiply by 1000, and here mass of the solvent, mass of solvent, right? So here mass of solvent. So this is how you can calculate molality of the solution. Okay, so this is how you can calculate molality. Molality is independent of temperature, just like a mole fraction and mass percentage. I already discussed with you, in any concentration defining term where mass comes into the picture, they are independent of temperature. Or whereas in case of the volume, they directly depends upon the temperature, right? So molality is independent of temperature. What is the unit of molality, beta? It is nothing but gram mole or kg per kg of solvent. Okay, that is the gram moles per kilogram of solvent. So this is how you can calculate the unit of molality, right? It's clear to everyone? Molality. Okay, now what is the relation between molality and the weight percentage? So we can express there the simple relationship between molality and the weight percentage. Weight percentage, whenever in question, when the given that is 20% weight by weight, or we say 10% weight by weight solute is given, it means this is weight percentage, means 10 gram out of 100 gram, 20 gram out of 100 gram. This is all about the weight. Okay, so this is all about the weight percentage. So the relation comes out to be m is equal to 1000 into my weight percentage of solute divided by 100 minus x into molecular weight of the solute. So this is the relationship between molality and weight percentage. So if you want to solve the question by using direct formula, you can use this. Instead, you can also correlate this two formula by using simple tricks like how will you find the mass of the solute solution. Then you can also find the mass of solvent. Okay, because we know that solute plus solvent is equal to mass of the solution. Okay, now the second important relationship between molality and mole fraction is this. That is, mole fraction is equal to m1 plus 1 upon m plus m1. What is m and m1 here, beta? M1 is the molecular mass of the solvent and m is the molality of the solution. Okay, so this is how you can calculate. This is the relationship between molality and molarity. So if the two terms are given, molality and molarity, and someone asks, how will you calculate molality or molarity by using each other, then you can use this formula as a relation. That is, molality is nothing but m upon d minus m into m2, where m is what? Where m is the molarity, d is a density, and m2 is what? Where m2 is the molar mass, right? So you can calculate by using this formula, right? Now, let's see one simple question. And by doing this question, we understood the entire concept about the relation between molality, molarity, density, and okay. So what the question asks, beta? Please read the question very carefully. In this question, they are asking, a solution of glucose in water is leveled as 10% weight by weight. What do you mean by this term, 10% weight by weight? Tell me. 10% weight by weight. What does it mean? 10% weight by weight. Yes, beta. This is mass percentage. This is mass percentage, means 10 gram of solute present in 100 gram of the solution. Right. So this is the actual meaning of the percentage. That is, 10% means 10 gram of the solute present in the 100 gram of the solution. Right. So in this question, it is very much clear, that is, mass of the solute. Mass of the solute comes out to be 10 gram. Okay. Mass of the solution. Mass of the solution. We know because percentage is given now. So what is the mass of the solution, beta? 10% means out of 100. It means 100 gram. So this is the mass of the solution. Okay. You have to calculate what should be the molality. So you have to calculate molality. So just write molality. You have to calculate molality of the solution if the density of the solution is given. So what is density, beta? Density is nothing but 1.2 gram per milliliter. Okay, 1.2 gram per milliliter. And you have to calculate the molality. First of all, what step you need to do, beta? First step is what? Just write the formula for molality, because in this question you have to calculate molality. So for doing any numerical, any kind of numerical, कोई भी numerical आता है ना, जो भी निकालना है, सबसे पहले उसका formula लिख दिया करो. Then you got to know what quantity you needed to calculate this. ओके उसके बाद से एक एक क्वांटिटीज को हमें कैलकुलेट करते जाना है, राइट? सो इन दिस यू हैव टू फाइंड मोलैलिटी. So just write the formula of molality. So what is molality, beta? Molality is nothing but mass of solute divided by molar mass. Okay, multiply by 1000 and divided by mass of solvent. Important note here, mass of solvent, not volume of the solution, because this is molality. Okay, so this is mass of solvent. Now What is mass of solute here? We know that mass of solute is nothing but 10 gram. What is the molar mass? So, a solution of glucose. We all know that glucose having the molecular formula, what beta? What is the molecular mass of glucose? Can anyone explain? Molecular mass of glucose? C6, H12, O6. So having molecular mass 6 into 12 plus 12 into 1 plus 6 into 16. So it comes out to be 180 gram per mole. So this is the molar mass. So this is the molar mass of glucose. So molar mass of glucose is nothing but 180. Now 1000 means 1000. What is mass of solvent here? This one is very important question here. What is mass of solvent, beta? Can anyone explain? What is mass of solvent in this question? We know mass of solution. We know mass of solute. So how we can calculate mass of solvent? Can we calculate mass of solvent if we know mass of solute and mass of solvent solution? Yes. This is very important and this is very simple one. In our first class, we are discussing this thing that how will you calculate mass of solvent using solution and this and by using this, right? Okay. So how we can calculate? Yes. We know that solute plus solvent is equal to solution, right? We know that solute plus solvent is equal to solution. Now we know that mass of solute is here 10 gram. You have to calculate mass of solvent, right? And what is mass of solution here, beta? 100 gram, because this is weight percentage, 10% means total mass of the solution is 100 gram. So what is the solvent mass? What is the mass of solvent, beta? It comes out to be 100 minus 10, that is 90 gram. Now it is clear to you, that is 90 gram. Just solve this. There is no role of density in this question, right? There is no role of density in this question. So 0 by 0 cancel. So what you'll get, beta? That is 100 divided by 100 divided by 18 into 9. Okay, so calculate solve this value, beta. What you will get? On solving, you will get 0. Molality comes out to be 0.617 molar, right? Or we can say it will comes out to be 0.62. So this is the molality of this solution. So the correct option is B. I hope is it clear to everyone? सबको समझ आया अच्छे से? किसी को कुछ भी डाउट हो तो प्लीज पूछ लो एक बार मेरे से. सबको समझ आया किस तरीके से यूज किया? क्लियर? ओके, ठीक है, राइट. सो this is the way how we can solve the question related to molality and molarity. So this one is very important question, and this type of question they are generally asked related to this topic only. Okay, so this is how you can calculate this. On the similar basis, one another question is there, that is an m molar solution. Here molality is not given. M molar solution of compound in benzene has a mole fraction of the solute equal to 0.2. What is the value of m here? So m and a m molar solution. So what is molar and molar, beta? Can anyone tell me what do you mean by this term molar and molar? So molar means molality. Molality, where molar means molarity. ठीक है? Molar means molality, where molar means molarity. So this is the, basic way to differentiate molar and molar. Now, an M-molar solution. So this is molality is given. A compound in benzene has a mole fraction of the solute equal to 0.2. So we know that what is mole fraction, beta? We know that mole fraction means what? Mole fraction in this solute. Mole fraction of the solute is equal to this. So M molar solution of compound in benzene. So I don't know which compound is this. So this is the solute. And here the solvent we use is benzene. So solvent we use is benzene. An unknown solute. Okay. So mole fraction of the solute is equal to 0.2. So if the mole fraction of solute is equal to 0.2, then what do you mean by the mole fraction? How we'll calculate mole fraction of solvent, beta? That is benzene. So we know that mole fraction of solute plus mole fraction of solvent is equal to 1. We know this thing now. So we can calculate by just subtracting 1 minus 0.2. So mole fraction of solvent comes out to be 0.8. This is clear to everyone? Because the mole fraction of, that is XA plus XB, is equal to 1. We already derived this. So if we know the mole fraction of solute, then we can easily calculate the mole fraction of solvent by just subtracting with 1. So it comes out to be 0.8. So we know the mole fraction of solute, we know the mole fraction of solvent. Then how will you calculate molality, beta? So we know that molality is nothing but equal to number of moles of the solute, that is number of moles of solute divided by per kilogram of solvent, right? Divided by per kilogram of solvent, per kg of solvent, right? Per kg of solvent. So how we can calculate number of moles of the solute? So here the mole fraction of solute is already given. So can you calculate number of moles of the solute if the mole fraction is given? We know that what is mole fraction? So mole fraction of solute is nothing but number of mole of solute divided by number of mole of solute plus number of mole of solution. This is how you can calculate now. Okay. So if the mole fraction is 0.2, so mole fraction is given, it says 0.2. Number of mole of solute you want to calculate. Number of mole of solute. So what is the number of mole of solution here, beta? Number of mole of solution, because in this we use benzene. So mass upon molar mass. So molar mass for benzene we already know. So just using this concept you can calculate. Or by using direct formula you can also calculate this. You have a two option. Either you calculate number of solute by using these two equation. That is equation number this and the next equation, that is equation number second. So by using this or by using the direct relation, you can calculate this question, right? We know that the relationship between mole fraction and molality is given. That is mole fraction is nothing but m into m1 plus 1 plus m into m1, where m1 is the molar mass of the solvent. That is already given. This is benzene now. So benzene comes out to be 78. We know that. Now, so we just put the value of mole fraction of solute, which is equal to 0.2. And this is small m, multiply by 78 plus 1 plus m into m. So just by solving this, we calculate m. So this is another very simple way to calculate the value of molality. So in such type of question, where it requires large amount of relation or large amount of calculation, just use this. Okay, just use this relation, simple relation. So by using this simple relation, you can calculate beta molality. So this is the way to calculate the molality of the solution. Got it? Okay. I hope is it clear to you? Okay. Now let's move to the next topic, that is Raoult's law. So what is Raoult's law, beta? We already discussed all concentration defining terms, right? So here is the next important topic, that is the Raoult's law. So in this we are going to study what beta, that is liquid into liquid solution. That is what happened when the one liquid which is act as a solute and other liquid which is act as a solvent, when they combine each other, when they combine with each other, when we mix this solute and solvent each other, then what kind of behavior, what kind of result we can observe. So here we are going to see such result that under the case of Raoult's law. Okay, so Raoult's law are the basically these law state the relationship between the mole fraction and the vapor pressure, that what happened when the one liquid is mixed with the another liquid, right? So what is the Raoult's law, beta? So according to this law, for the solution of two miscible liquid, just remember this fact, for the solution of two miscible liquid, the vapor pressure of each liquid in the solution is less than the respective vapor pressure of the pure liquid. What do you mean by this term, beta? It means this is, let's understand through example. So this is liquid number A, right? And this is liquid number B. This is liquid number B. When we mix each other, liquid A and liquid B, we get liquid A plus liquid B. So this is liquid A plus liquid B. This is what we get, right? Liquid A and liquid B. So according to the Raoult's law, the vapor pressure of the pure liquid, right? The vapor pressure of the pure liquid is more as compared to when these two liquid are mixed with each other and the resulting vapor pressure, right? So for the solution of the two miscible liquids, the vapor pressure of each liquid in the solution means when they mix with each other. For example, one act as a solute. For example, liquid act as a solute and liquid will act as a solvent, and they combine together to form solution. So according to the Raoult's law, for the solution of the two miscible liquid, the vapor pressure of each liquid in the solution is less than the respective vapor pressure of the pure liquid. It means जो pressure liquid A और liquid B का था, उसका प्रेशर जब उन दोनों को मिक्स कर दिया तो प्रेशर कम हो जाएगा. यानी लिक्विड A प्लस लिक्विड B का जो वेपर प्रेशर होने वाला है वो कम होगा एज कंपेयर टू जितना लिक्विड A और लिक्विड B का पहले था, इनिशियल था, जब उसको मिक्स नहीं किया था, right? And at the equilibrium, partial vapor pressure of the liquid is directly proportional to its mole fraction in the solution. और ये किस पे डिपेंड कर रहा है? Mole fraction of this solution. So I hope this is clear. What is Raoult's law state that? Clear to you? What is the Raoult's law? That is for the solution of two miscible liquids, the vapor pressure of each liquid in the solution is less than the respective vapor pressure of the pure liquid. And at the equilibrium, the partial vapor pressure of the liquid is proportional to this, right? So this is how we'll write the Raoult's law, right? So let's see how will you mathematically derive the Raoult's law. Okay. So we know that according to Dalton's law, that I study in our 11th class, right? So according to the Dalton's law, we can write like, according to the Dalton's law of partial pressure, the total pressure over the solution phase in the container will be the sum of the partial pressure of the component of the solution. For example, if you want to calculate the P total is nothing but equal to PA plus PB. Now substitute the value of PA and PB. What do we get, beta? We get the P total. So what is P total here, beta? P totals comes out to be XA into P naught A, that is the vapor pressure in pure state, multiply by its mole fraction, plus vapor pressure in the pure state B multiply its mole fraction, that is XB. And we know that XA plus XB is equal to 1. So this comes out to be XA is equal to 1 minus XB. So this PT comes out to be this, yani total pressure total vapor pressure is equal to P naught A plus P naught B minus P naught A multiplied by its mole fraction. Okay, so this is known as Raoult's law for volatile liquids. So this is known as Raoult's law. So this is known as Raoult's law for volatile liquid, right? So this is known as Raoult's law for a volatile liquid. Okay, volatile solute, or we can say volatile solute. Volatile solute, because volatile means what? Volatile means something which is liquid, which vapor can be formed, which can be capability to form the vapor. Okay, so this is all about the Raoult's law. Okay, now what is the ideal solution, beta? If someone asks what is ideal solution, so according to the Raoult's law, you can define which solution is ideal and which solution is non-ideal. So ideal solution are those which obey Raoult's law over the entire range of the concentration. It means the total pressure comes out to be this, that is P naught A plus P naught B minus P naught B into XP. So if the solution follows these law, then we can say this is a ideal solution. So ideal solution are those which obey Raoult's law over the entire range of concentration at a given temperature. Now, what is the characteristics of an ideal solution? So characteristics of an ideal solution, like these obey Raoult's law. This is the first point. The second point, delta H of mixing is equal to 0. It means if we mix two liquids together, then there is no energy evolved or absorbed on mixing. So this is mean delta H of mixing. So delta H of mixing 0 means what? There is no energy which is to be evolved or absorbed on mixing these two liquids, right? Similar, delta V of mixing is equal to 0. What does it mean? It means on mixing, no expansion or contraction occurs. Right? So delta V of mixing is equal to 0 means on mixing, there is no expansion or contraction occurs. So this is the characteristics of an ideal solution. Okay, it means delta H of mixing is equal to 0, delta V of mixing is equal to 0. Okay, can anyone explain me what is the effect on delta G, that is gift free energy? So we know that delta G is equal to nothing but delta H minus T delta S, right? So if delta H is equal to 0, what does it mean? Delta G is negative. Delta G comes out to be negative. It means it will spontaneous. Okay. So what is the sign of delta G for an ideal solution? It is negative. So we know so we get to know what is the sign of delta G, delta H, and delta V. So delta H, that is enthalpy of mixing, is equal to 0. Delta V means volume of mixing is also 0. And delta G, that is a gives free energy. It comes out to be negative for an ideal solution. Or we say the reaction is spontaneous. Now, what are the examples? So what are the examples of ideal solution, beta? Can anyone tell? Yes. So this is the example of ideal solution where the vapor pressure in the solution is equal to vapor pressure in the pure state, right? So it comes out to be, beta, what? That is benzene and toluene, N-hexane, N-heptane, ethyl iodide and ethyl bromide, chlorobenzene and bromobenzene. These all show ideal behavior. It means these are the example of ideal solution. So many times questions come related to this thing only. That is, what are the example of ideal solution? What are the condition? What are the characteristics of ideal solution? So these things you must remember. That is, what is the sign of delta S, delta V, delta G, and examples. Okay. So benzene, toluene, again I am repeating, N-hexane and N-heptane, ethyl iodide and ethyl bromide, chlorobenzene and bromobenzene. These are the example of ideal solution. Now, how will you represent ideal solution? So there is a graphical representation of ideal solution. So let me show how will you obtain this graph, right? So to do this, to obtain this graph, do one thing, right? On x-axis, take mole fraction. So here I am taking mole fraction of B is equal to 0 and mole fraction of A is equal to 1. Now, as we go along the x-axis, mole fraction increases and reaches up to xb is equal to 1. So obvious here x is equal to 0 because the sum of mole fraction is always 1. So if one is present in maximum amount, then other is present in minimum amount. Now we know from the Raoult's law, that is what is PA beta? PA is nothing but P naught A into XA. That is the vapor pressure in the pure state multiplied by the mole fraction. Similar, what is PB? PB is nothing but P naught B into XB, right? That is P naught B into XB. So this is about the PB, that is the vapor pressure, PA and PB. So we know this for such kind of equation, we know that Y is equal to mx plus c. This represents the straight line graph. We all know that Y is equal to mx plus c represent the equation for the straight line graph. Okay, so this is resemble to this only, that is PB and PA. So for PB, as the mole fraction increases 0, we get this curve, like straight line curve. Got it? This is. So at this value, when the mole fraction of XB is equal to 1, this will get pure pressure. Yani this is, here we get P naught B itself. Right? Because in this, there is no mole fraction of A. Mole fraction of A is 0. Here, totally mole fraction is XV is equal to 1. It means here only XV is present. Only pressure is present due to the solution. Solute of B only. Right? So, similar, if you draw the curve for PA, so we get like this. Here we'll get P naught. Here we'll get P naught A. Right? Here we'll get P naught A. So this is for this. Now this is the total. So this represents the total pressure, which is equal to PA plus PB. So this curve we obtained in case of ideal solution. So this is all about. So this is the curve. That is a vapor pressure behavior of ideal solution, which is obeying Raoult's law. So this is the graphical representation of ideal solution. How will you represent ideal solution using a graph? Okay, so this is the PA, yani vapor pressure of A, and this is the vapor pressure of B, and this curve represent the PT, that is the total vapor pressure, which is comes out to be PA plus PB. Always remember one thing, that is the total vapor pressure of the solution is lie between the vapor pressure of the A plus B. Okay, so if the vapor pressure of A is 300 and the vapor pressure of B is 500, then the total pressure must be lie between 300 to 500. Okay, so this must be lie between 300 to 500. Okay, so this is how we'll actually represent the ideal solution. So these are the graphical representation of ideal solution. I hope this is clear to you. Any doubt related to this, beta? No? Okay. Now, then what do you mean by the term non-ideal, or we say real solution? So what is non-ideal or real solution? So basically non-ideal solution means they are those which do not obey Raoult's law over the entire range of concentration at a given temperature. It means they are those which do not obey Raoult's law, where the ideal solution obey Raoult's law over the entire range of the concentration. So they are those which do not obey Raoult's law over the entire range of concentration at a given temperature. For example, we can say in this PA is not equal to P naught A into XA, and PB is also not equal to P naught B into XB. Yani for such mixing, delta H of mixing is equal to 0. Delta V of mixing is also not equal to 0. Right? Yani non-ideal solutions show the following two types. What two type beta? Either if these are not equal to, if the PA is not equal to P naught A into XA, then what two possibilities arise? Either it will be greater than this, either will be less than this. So we are getting two possibility. If the vapor pressure comes out to be more than what you expected, then it is called positive deviation. If the vapor pressure is comes out to be less than what we expected, then it is called negative deviation, right? So let's see first solution showing the positive deviation. So the vapor pressure of each component in such a mixture is more than what would be expected on the basis of Raoult's law of component A and B alone. And why this is actually takes place, beta? How the vapor pressure of the component in the mixture become more than what would be expected. Similar, if the force of attraction between the solute and solvent is less, if the force of attraction between the solute and solvent is less, then more vapor will be produced because escaping tendency is more. Similar, when the force of attraction between the solute and solvent is more, then escaping tendency is less and less vapor will be observed, right? So in this, if the attraction between A and B molecule is less than the attractive force between AA and BB, then the escaping tendency in the solution is higher than either of the pure component. And for such deviation, PA is greater than P naught A XA and PB is greater than P naught B into XB. Or we can say that total pressure is greater than P naught A XA plus PB naught into X. Right? So here, delta H of mixing is also greater than 0. So delta H of mixing comes out to be greater than 0. As the new bonds formed are weaker and energy is absorbed, so delta V of mixing is also greater than 0. Just remember one simple thing. In case of positive deviation, delta H of mixing is also greater than 0 and delta V of mixing is also greater than 0. And why delta H of mixing is greater than 0, beta? Because as the new bond formed are weaker and energy is absorbed. So this is the reason why the new bond forms are weaker and delta H become negative, greater than 0, or we say positive. Similar, delta V of mixing is also greater than 0. It will also positive. There is an increase in the volume. Now, how will you represent non-ideal solution, or we say positive deviation, through a graph? So we can actually represent this through a graph like this. So in case of ideal solution, we know that we get this dotted line, right? So in case of positive deviation, what we get, beta? We get nothing but just increase the pressure. For example, PB. So PB increased by little amount, this increased by this factor. Similar, PA increased by this factor. So total fraction is also increased. So this is how we can get the graphical representation of non-ideal solution having positive deviation, right? क्या करना है? बस थोड़ा थोड़ा सा पीवी को देखो आपने इंक्रीज कर दिया, जैसे पीए का कर्व ये था तो इसमें प्रेशर बढ़ गया ना थोड़ा सा, तो थोड़ा सा ऊपर कर दो इस कर्व को. सिमिलर वे में पीवी का कर्व ये डॉट वाला था तो इसमें आपका प्रेशर बढ़ गया, पॉजिटिव डेविएशन है, थोड़ा सा ऊपर कर दो, तो जो इसका रिजल्टेंट होगा वो भी तो बढ़ जाएगा, पी टोटल. तो इस तरीके से हम लोगों को ये वाला ग्राफ मिल जाता है, राइट? नाउ व्हाट आर द एग्जांपल ऑफ पॉजिटिव डेविएशन, बेटा? That is ethanol and water, ether and acetone, carbon disulfide and acetone, carbon tetrachloride and methanol, cyclohexane and ethanol, water methanol, carbon tetrachloride benzene. So these all are the examples, right? So these all are the examples of positive deviation in which the force of attraction between the solute and solvent is less as compared to force of attraction between solute and solvent. Right? Now, let's see the solution showing the negative deviation. So what type of solution showing negative deviation, beta? So for the such solution, the partial vapor pressure of each component is less than what would be expected on the basis of Raoult's. For example, in such a mixture, the attraction between the molecules of A and B, just opposite of positive deviation, right? In such mixture, the attraction between the molecules of A and B is greater than the force of attraction between AA and BB. As a result of this, escaping tendency of both the component are lowered. And due to this, the vapor pressure is decreases as what we expected from the Raoult's law. That is, PA is less than P naught A into XV and PB is less than P naught B into XB. So we can also say that the total pressure also comes out to be less. That is, the total pressure is less than what we expected from the Raoult's law. Right. So for such solution, delta H of mixing is less than 0. That is, heat is evolved due to the formation of a strong bond, right? And delta V is also less than 0. That is, it comes a volume of the solution become negative. Now, what is the graphical representation beta of non-ideal solution? So this is the graphical representation. This dotted line represents the ideal solution. Just decrease the value like this PA, and this represent PB. So the total pressure also decreases. Okay, so this is very much similar and opposite to the positive deviation. So what are the example? Example like acetic acid and methanol, acetic acid and pyridine, acetone and aniline, acetone and chloroform, benzene and chloroform, water and hydrochloric acid, water and nitric acid. Basically, water and nitric acid, or in water, hydrochloric acid, there is a hydrogen bonding involved. And due to this only, the bond becomes very strong. And if the force of attraction between the solute and solvent increases, then definitely the escaping tendency decrease. And due to this only, they show negative deviation. So I hope, is it clear to everyone? That is what is negative deviation, what is positive deviation, and what is the two factors, right? So this is all about the Royle's law and the type of deviation that we can observe basis on the Royle's law. That is, the Royle's law basically defined for the liquid into liquid solution, and there are two types: ideal solution and non-ideal solution. For the non-ideal solution, classify into the two types, that is positive or negative deviation. So I hope it is clear to everyone. That is what is how we'll identify which is a negative deviation, what is the cause behind the negative deviation and all. Okay, so this is all for the today class, and in our next class we are going to discuss about the azeotropic mixtures and do some concept question that are basically based on the Royle's law. Okay, so let's meet in the next class, and then we are going to discuss about the questions related to this topic only.